So to start off this unit, we're going to start off talking about polygons. So what the heck's a polygon?
A shape.
Well, that's specific.
Five-sided shape.
It's a five-sided shape. Oh.
Polygon?
Yeah, what's a polygon?
It's a shape with straight lines.
Oh, so so this could be a polygon then, because it's got a straight line in it.
No.
Like
Oh my gosh.
Like
all straight lines
made
connected.
of straight lines.
All straight lines? There, that's all straight lines. Connected?
Oh. Alright, guys, are good.
Yeah, I guess.
Yes, technically.
I mean, that could be.
No.
Nope, it's self-intersecting. Nope.
Oh, wait.
Well, you gotta erase that part.
You just delete
No,
I
so
see a pentagon.
Don't do that.
Straight lines.
Okay.
Like connecting that do not intersect.
What about that guy?
That's a circle.
That is a circle. Is that a polygon?
It's a straight.
No, because polygon means multiple.
Jackson is so
Poly
bad.
means multiple.
So wouldn't this be an infinite-sided gon?
Infinigon.
Got
Okay. Shh. So, examples of a polygon. Okay, whole bunch of them here. To make a polygon, it's got to be closed. That's when they were saying they've got to be all connected. And they can't overhang. So something like that is not a polygon. See, there's that little tail hanging out the end. Okay, so it's got to be completely closed, and it's got to be a plane figure. What does it mean when it's on a plane?
It's two-dimensional.
It's 2D. It's flat. It's not 3D. When you get 3D, you get, all sorts of stuff, like, icosahedrons and dodecahedrons and tetrahedrons and all that goofy stuff. And you don't want to do that until Unit 13 at least. Okay?
Whoa.
Unit 13 is our 3D unit.
we have 13 units.
Yes!
How do you know that?
Hey,
Okay, shh. Oh, wait, hold on. We're not done.
No, we're not.
Because this is a closed plane figure.
But does that
But you said it wasn't a polygon, so it's got to have, it's got to have sides that are formed by line segments. So with 3 or more sides that are line segments. Because if you try and draw a shape with only 2 sides in a 2-dimensional plane, it doesn't work so good.
I've got a 3D plane.
Well, that wouldn't be a plane then, that would be 3D space. And what you would have if you tried to draw it is you'd basically have a triangle floating in 3D space. But if you're just on a plane, it's not possible. You end up with that. And as close together as you make them, it's either just a V or it collapses into a single line segment. Okay? So here are a bunch of numbers of sides that polygons can have. See how many of the names you can fill in. Go.
Alright, let's go.
See what you remember from back in your dark childhood.
Triangle. Rectangle.
it could be a square. I'm gonna put a quadrilateral.
Hold on, guys, I got this. Here, I'm gonna do the hard ones first. Dodecagon.
No, hexagon is six.
Dodecagon. I got what Tina was doing. Yeah, it says no. Wait, is dodecagon?
What is an N? Sextuple.
It's a number. The N is representing a number that you just don't happen to know.
Pentagon.
No, it could be any number you don't happen to know.
Seven.
I have.
Set.
Other pocket. Are you sure?
I actually saw it at HEB. Let's see, it was before or after Christmas?
What's 10?
Like a 10. What's 7?
10 ago.
A Septicon is 7 because September is the 7th.
Well, here's, if you connected the points on that, that would have 7 sides. Okay, so a 3-sided polygon is called a triangle.
It's December gone.
A 4-sided, but a rectangle is, this has 4 sides, but it is not a rectangle. So this is going to be a quadrilateral. Okay? Because you need to be a generic name that fits anything that's got that many sides. Okay? 5-sided shape?
Pentagon.
That's a pentagon, and you know that the pentagon where the CIA is actually shaped like a pentagon, right?
Yeah.
Yeah?
That's cool.
It is really cool. I appreciate that architecture. A 6-sided shape?
Hexagon.
It's a hexagon! Hexagons are bestagons.
I thought she said 7.
What if it was the pentagon was a triangle? Would they call it a triangle?
I'm sorry, what?
What if the pentagon was a triangle?
I don't know if they would. Maybe. Okay. All right, for candy. Who knows the name of a 7-sided polygon? Oh, some people chickened out. What do you think? Okay, so, caveat. Yes, technically septagon works.
There's another name.
Yes, and the thing is septagon starts with an S. But for the 6-sided thing, we started with an H for hexagon. And so if we did hexagon for 6, then we need to do heptagon for 7.
It's both right.
If you're using septagon for 7, then you have to use sexagon for 6, and that just makes teenagers giggle. And so,
Wait, why do you have to use it? Like, if...
to show that you have a consistent pattern. Shh. Oh, but if we like patterns, do you notice that the last 3 have ended with gone?
Yes.
Yes.
So what's an 8-sided one called? Octagon. Just like the octonauts. Okay, let's try again for candy. Raise hand. 9-sided.
Pentagon?
Nope.
No.
Yeah? That's a nonagon.
That's what I said.
No, you said
No, I
nanagon.
said nonagon.
You said nan.
The kid just stole my candy.
Stop gaslighting me. Okay. 10-sided shape. You already had a try.
Actually, I'm gonna do 12.
10-sided? It's a decagon.
Oh, I had that.
Like a decade has 10 years, a decagon has 10 sides. Okay. 12.
Dodecagon.
It's a dodecagon.
See? Y'all gotta trust me. I know my facts.
Okay, hold on. Shh. We did skip one.
11.
What's an 11-sided polygon called?
I'm in 11 shit.
Candy for that. 11-sided is technically a hendecagon, but that just makes me think of a chicken-gon, and I don't want to do chicken-gons. So we start getting lazy for a lot of these ones that have more sides, and we use the number as its name. So instead of hendecagon, a lot of times you'll just hear that called an 11-gon. And guess what a 13-sided polygon would be? A 13-gon. And it goes from there. Now, there are technical names for these. I had somebody in my last class ask, what's a 40-gon called? So we looked up 40, and it's a tetracontagon.
Like Tetris?
Well, shh. So you're getting into this. Notice how all of them have gone except for the first 2.
Yeah.
Let's fix that. What would you call it if it's a 3-sided shape that has...
Trigon.
That would be a trigon. Sounds like the Transformers. Okay. So what would it be for a 4-sided shape?
Quadron.
Actually, it's not a quadrigon because it's coming from a different language. This would be a tetragon.
It's like a...
Is that Latin?
Well, the Latin would be quad,
Oh, yeah.
and so this is the Greek. And so, interestingly, how many of you ever played Tetris? You know why it's called Tetris?
Yes.
There's 4 little blocks in each of those shapes that you're dropping. And so they're called, it's Tetris because that's what those things are called. Okay. Shh. Now, we further subdivide the polygons into two groups. You are either convex or you are concave.
The end
I've heard this before.
Oh, you're right.
I thought you called something.
The n number of sides.
candy.
Well, okay, if we had an 11 gon for 11 sides, and a 13 gon for 13 sides, what do we call it if we don't know the number, but we know there is a number? An n gon, because it has n number of sides.
Why does it have to be N?
For number of sides.
Can it be X gon?
You could use the letter X, but just be aware that the standard format that mathematicians use for the number of sides of a polygon is n. And so you're going to see that on all of our stuff, is the n for the number of sides. Okay? So, if you have a convex or concave, what's the difference? Okay, I want you to think back if you've ever heard the words convex and concave. In general terms, what does concave describe?
Enclosed.
No, that's closed.
Oh.
What's concave?
Is it zoomed out?
Nope.
Collapse.
Not zoomed in or zoomed out.
Yeah, concave, like collapse.
I've heard of it. It has to do with cylinders, right?
You remember it because its sides are caved in.
I knew I had to say cave.
Okay, shh. So, here is an ordinary convex shape. That's kind of the standard, is for things to be convex. This is a convex pentagon. Here is a concave pentagon.
Whoa.
Because the top has caved in.
Wild. Looks like a crown.
Right? So, okay. Let's see.
I don't know too many.
So a convex, okay, what was a convex dodecagon? That was a 12-sided shape, right? You want to draw one of those?
No.
They're kind of hard.
Let's do it.
You know what's easy to draw? A concave dodecagon. I just drew 12 marks. And it's concave.
2, 4, 6, 8. Oh.
There's 3 on each part.
No way. Never knew that.
Can you draw a convex quadrilateral?
Probably not.
Draw a convex quadrilateral.
Oof. That's gonna take a little bit.
Don't look at this,
Boom.
okay?
How do you know if it's...
Because it'll be...
Quadrilaterals have how many sides? 4. So, something like that?
Yeah.
Okay, if I, just an ordinary shape, could a square be a convex quadrilateral?
Yeah.
Sure. Can you draw a concave quadrilateral?
No.
Looks like a plus.
No?
I'm thinking, you know.
Like that, just there. It's like a
Ooh.
plus, not a Swiss.
Like a little bird.
It's actually called a dart.
Triangle.
Y'all know the Swiss.
Okay.
Okay, I can draw a convex triangle. Can I draw a concave triangle?
Don't think so.
No. Not in Euclidean geometry.
Oh, wait.
Okay.
I'm not a big fan of non-Euclidean.
Can you draw a 2-sided polygon?
No. I think so.
Can you draw a 2-sided polygon?
No.
Yes. That's a
No, because it'd either be a V or like...
Yeah, it would either be a V or it'd be a segment in Euclidean geometry.
Yeah.
Y'all, where's my knot? But this right here is a bigon. It's a 2-sided shape. One side, the yellow part is a bigon. This side is straight, I'm not turning, this whole
Like
way
an
is.
apple slice.
Yeah, or an orange wedge, or whatever.
Wedges with flat.
But this is non-Euclidean, do you want to do some non-Euclidean this unit?
I'd do
Yeah.
that.
Some people were like, yeah, but I heard no's, so I guess we'll go with the no's.
What is this?
Okay? Shh. So, how can we describe caved in mathematical terms?
It goes to
It
the
collapsed.
center.
The way we define it is by saying that if you can find any vertices that you can connect outside the shape. Okay? So lines can be drawn between vertices that are outside the shape. And you only need one to make it be convex. So this first one only has one. You only need that one to draw. What about this plus-looking guy? Can I draw connecting vertices outside of the shape?
Yeah.
Yeah, I could do these ones, or I could do down here. There's several of them, but it only takes one to make it be concave. And then over here, I can do it across the top there. Okay. For a convex polygon, okay, any line segment between vertices is either a side of the shape or inside the shape. So a line connecting vertices is a side or inside the figure. So if I want to connect this top point and the adjacent point next to it, does that go outside the shape at all? No, it's one of the sides. But I could try and connect it down to this guy. Does that go outside? No, it's completely inside. So this is a convex figure. Okay? Nothing escapes. It's all either inside or it's one of the sides. Okay? Concaved ones are pushed in somewhere, so a line can end up being left outside. Okay? Questions so far? You're going to hear us talk about convex and concave. Assume that we're talking about convex unless we say concave. Okay? Just assume it. Otherwise, everything gets goofy. Okay? So, is the following figure a polygon? Yes or no?
Yes.
Yes, it is. It is closed, and it has line segments for sides. Has 3 or more of them. So tell me some of its attributes. What can you see about this particular polygon?
Closed off.
It's closed, but that's part of being the polygon, so I don't have to write it separately.
Oh, so it's a two-dimensional.
That's also part of being the polygon, so I don't have to write it separately. It has 6 sides, which means it is a
Hexagon.
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 Guys.
What else? It is convex. So it is a convex hexagon. Are all of its sides the same length? No. Do they all always have to be the same size? No. If they are, though, turn to the 3rd page. A regular polygon is a polygon that is equilateral and equiangular. Okay? So sometimes polygons have all the same sides and sometimes they don't. And we're going to get a whole bunch into that in this unit with our quadrilaterals, where you're going to have to pay attention to whether or not the sides are the same length or not. Ooh, it's going to be fun!
All right.
Okay? So, going back to the first page then. If this one's not regular, what is it? Irregular? Okay, whatever. If I don't tell you it's regular, you need to assume it is not. And if you look at a picture and it looks regular, but I don't tell you, guess what? It's not. Don't trust the pictures. Okay? You gotta have the little mark saying they're the same size to have proof that they're the same size. Okay, what's a diagonal? Okay, well, before we try and describe it, let's see if you can draw it. Can you draw a diagonal in a triangle?
Yeah.
No, I don't think so.
Who says yes? Who says no? Let's try that again because that was not everybody. Who's going on the yes side? I think that yes, you can draw a diagonal in a triangle.
Actually, I'm going yes.
Okay. How many think now you can't draw a diagonal in a triangle? Okay. Now, let's look at a quadrilateral. Can you draw a diagonal in a quadrilateral? Okay. Pick one corner and draw however many diagonals you can draw from it.
That makes sense. Okay, I got you. Diagonals, it's infinite.
And you can draw exactly one.
Oh, then I
Okay.
should try it.
Now, we're sticking with one corner at a time.
Alright.
Okay? Go to, what's this five-sided guy? Pentagon. And this is actually how the Pentagon is shaped in DC. I've seen it from a helicopter above it. It really is cool. Okay? Pick a vertex.
Were there any aliens there?
Draw all the no, that's Area 51. Or Roswell.
I think they have them in the Pentagon.
Get it right? No. They keep all those in Area 51. Okay? Draw all the diagonals from this point in the Pentagon. Okay. When we go to the hexagon, do you think there will be more diagonals or fewer diagonals? Okay, draw them. Pick one corner, one vertex, and draw all the diagonals you can just from that one vertex. Okay? Shh. Going back now to the triangle. Can you draw a diagonal in a triangle?
No.
Why not?
Because it's...
I need people to raise their hand. I heard no's from other voices. I want to hear the other voices. Why can't you draw a diagonal in a triangle?
Probably because it's against the rules.
You haven't given me rules yet. So what is the rule for a diagonal? What the heck is a diagonal?
So you gotta do opposite opposing third.
It's a what?
It's a line.
A line? Segment?
It's a segment.
Boy.
And what about that segment? A segment that does what?
Goes across to one versus to the opposite.
One vertex, so it connects. Connects what? Oh, any vertices? So is this is two vertices, is that a diagonal?
No.
Side.
So how do I make sure it's not one of the sides when I draw it?
Inside the...
You label it.
It's a segment that connects non-adjacent vertices. Because if they're next to each other, that's going to form a side of your polygon. It's when you're jumping past one, going across somewhere, that you end up having that kind of thing.
I need to put a hard one.
They told me to.
Professor Plus.
Okay. So, turn the page, and behold. Oh, is this looking familiar? Shh. Hi. We are going to focus this one, we are going to assume that these are pictures of regular polygons. Okay? And what I want you to do is I want you to fill in as much of this chart as you can. So let's look at the things you're going to be finding. You're going to be filling in the number of sides that goes with each one of these shapes. Then you're going to be finding the number of triangles you can divide it into using diagonals. And notice it's specifically from one vertex, just like we did on the previous page. Then I want you to add up all those angles and tell me the total sum. And then you're probably going to want to skip a line and come down here and find out how big each of the angles are individually. And then you'll probably want to figure out how big are the exterior angles. But wait a minute, who remembers from our triangles unit, what the heck is an exterior angle?
Oh. An angle on the outside?
It's an angle on the outside formed by a linear pair. Okay? And then go back and find the sum of the exterior angles of a polygon. So argue with each other, talk about it, see what you come up with. How many degrees are in a triangle?
180.
Oh, you're sure? Okay. Okay, just making sure. So that would make this be a 5-sided shape, and a 6-sided shape, and a 7, and an 8. Oh, and if it's got n sides, then it's got n sides. Okay.
I put infinite for n.
And then this triangle, oh wait, if I draw a diagonal here, I've made 2 triangles. So that's 180 and that's 180. And so I've made 2 triangles out of that shape. And they each have 180 degrees. So the sum of the interior angles of that guy is 360. Because this plus this plus this plus this plus this plus this is 360. Okay? Well, each interior angle then, oh, sorry, I didn't show you the picture. This, and this, and this adds up to 360 on the inside. Well, there are 4 angles in a regular quadrilateral, and if it's regular, they're all the same size. So I would take that 360 and I would divide it by 4. In a triangle, you did the 180 and divided by 3. Okay. So let's see what y'all came up with. I did the top row for you. You're welcome. See, if you had this shape, you had 5 sides. This shape had 6 sides. This shape had 7. This shape had 8. And this shape had n. And you don't know what it is, so you just put n. And no, we're not going to use x. We're going to use n, because that's what we like to use. Okay? So the number of triangles. Ooh, how many triangles did my pentagon get divided into? 3? What about my hexagon? It was 4. And my heptagon?
Like 5. Okay.
Would it be like 5 or would it be 5?
I'd say like 5.
It's 5. What about my octagon?
Probably
6? But I only drew 5 lines.
Well, it's 6 triangles.
But it makes 6 triangles.
Yeah.
Okay. And so, okay, so how many triangles can an n-gon be divided into?
N.
Wait, these didn't match. So why should it match here?
Well, because it's
Because
we don't know.
you don't know it.
Oh, but even though I don't know it, can I figure out how many triangles are in it?
N minus 1?
Well,
You do a...
it's n minus
2. That's
2.
I knew that.
Whatever your number of sides is, this is what algebra's for, is for figuring stuff out even when you don't know a number. If I have something to represent the number of sides, I just take away 2 to get the number of triangles that are inside it. Okay. Well, now that I've done that, okay, well, wait a minute. Each of these triangles is how many degrees?
180.
Each triangle has 180 degrees. So in a single triangle, there's a sum total of 180 degrees inside it. In a quadrilateral with two triangles, you end up with 360 degrees inside. For a pentagon, you've got three triangles that each have 180, so how many degrees total here? How much?
540 degrees.
540? What about for the hexagon that's got four triangles inside it? 720 degrees. What about for the heptagon? Something disgusting?
Or like 900.
900? You keep qualifying it instead of just going when committing to the number. Okay? And for an octagon that's got six triangles in it? 1,080 degrees! So, but look at these. Look at these angles. These are big ol' honkin' angles, aren't they? It makes sense that 8 of them would add up to that big a number. What about if I don't know the number of sides? Can I still figure out how many degrees are inside that polygon?
Probably.
How did I get each of these numbers? I took the number of triangles and multiplied it by 180.
And minus 2. Man.
So this would be to take the n minus 2 and times it by 180. Which of course you could memorize if you really wanted to, but I recommend you just remember, cut it into triangles, there's always 2 less, and then each of those triangles has 180 degrees. So, n minus 2 to get the number of triangles times 180 degrees. Okay, cool. Skip down. If it's a regular polygon, you're going to take that number and divide it by the number of angles it's got that are all the same size. So here, the 180 divided by 3, didn't we talk about equilateral, equiangular triangles always having 60 degrees? Uh-huh. And a regular quadrilateral is called a square. Guess how big its angles are?
90 degrees.
90. So if you've got a regular pentagon, how many degrees am I sharing out?
72.
I'm sharing the 540 total among how many angles?
5.
Among 5 of them, which gives you how much?
72.
108.
It's 108.
580.
Oh.
Okay?
Shamblinch.
So for a hexagon, we know the sum of all its angles is 720. But if I want just one of them, I need to divide it evenly by the 6 angles that are in there. And so what do you end up with?
Probably like 100.
Probably like 120, or is it actually
Actually 100.
120? Commit, y'all. Oh, for the heptagon! Dominic looks excited about the heptagon.
Oh.
We've got that 900 degrees divided by 7 angles. Is this going to be pretty?
No.
No. I think we should have to memorize this one. That would be fun to memorize, wouldn't it? No? I don't have overwhelming support for memorizing the number of degrees in a heptagon?
Nope. Nah.
Okay. What about for an octagon?
135.
135 degrees? What about for an n-gon?
And minus 2 times 180.
I'll take this number, so it happens to be n minus 2 times 180. That's the total number of degrees. And then how do I get just one of the angles?
Divided by the number.
Divided by the number of angles. It's simpler to just remember what you're doing than trying to memorize a formula, but I don't care. Some of you are good at memorizing. I am not good at memorizing, which is why I do math, because I can just remember the relationship. Okay? Okay. Now, remind me about an exterior angle. What makes an exterior angle? They're supplementary to the interior angles. So here, my interior angle was 60, so my exterior angle here was how big?
Probably like 120. I mean,
120 degrees, which is what it has. Okay? For my regular quadrilateral, it had an interior angle of 90 degrees. So how big is its exterior angle right there? Also 90 degrees. Okay? Well, here, you said each one of these angles here individually is 108. So how big is its supplement going to be? How are we going to find that? How do we find it?
Oh, you subtract.
Yeah, you're going to do the 180 minus the 108 and get 72 degrees for your exterior angle. Okay? As your interior angles get bigger, guess what happens to your exterior angles?
it's smaller.
They get smaller. So this interior angle is 120. How big is the exterior angle?
60 degrees.
It comes out to be 60 degrees, right? Oh, so I could do 36, I could do 60 degree angle. Ooh, I bet I could do some 60, 30, 90 triangles with that.
Oh,
Okay, so how big are the exterior angles of a regular heptagon?
51
Let's see, we would have to subtract this from 180, right?
Yeah, 51.4.
And it comes out to be 51.43 garbage, it goes on forever, and I don't care where you round unless I tell you otherwise.
It doesn't go on track.
yes, it does.
It doesn't?
It does.
The calculator on this one.
Well, that's if you use the rounded off version. But if you use the full version, it goes on forever. Okay, what about for an octagon? How big are its exterior angles?
45 degrees.
So how do I find how big each exterior angle is if I don't know how many sides there are?
No.
Well, how did I do these? I did 180 minus the interior angle, which was this big disgusting formula, right?
Yeah.
Ooh, that sucks. If only there was an easier way. Oh, wait a minute. We're going to find one. Really quick, if the exterior angles are 120, how many exterior angles are there in a triangle?
I'd say
Infinite. 3.
So guess what the exteriors add up to?
360.
The exterior angles of a regular quadrilateral are 90 degrees. Guess how many of those there are in a quadrilateral?
4.
So guess what they add up to in a quadrilateral?
360.
So all of them.
So for a pentagon, the exterior angles are 720, but guess how many there are? 5 of them. So guess how many degrees they add up to?
360.
Fill in the rest of that row.
Wait, is it like 360?
Well, let's see. 60 degrees for an exterior angle. There are 6 of them for a hexagon. That's 360. That's 360. So the sum of the exterior angles is always 360. Okay? Okay? But wait a minute, wait, hold on.
What?
So, instead of doing this big long thing for finding my exterior angles, how many degrees are always summed on the exterior of a polygon?
360.
And if I want to find how big each one is, couldn't I just divide it by how many angles there are? Okay. And that will give me my exterior angle. Do some algebra on that. Guess what? If you rearrange that a little bit, if you ever need n, it's always going to equal 360 divided by the measure of your exterior angle. rather than having to use these disgusting formulas. Okay? I would hang on to this because that's going to be very useful in today's stuff. But let's finish filling it in and then I'm going to give you something to do. Don't die. Stay alive.
Have a nap break.
I think they should honestly have a nap time for high schoolers, but alas, I don't make the
They
rules.
should.
Naps are wasted on the young.
They don't need them.
They don't want them. Do you know any 6-year-old who just wants to go laying down instead of playing? No, they always go playing. Okay, so let's see what you remember. The sum of the interior angles of a polygon. How do you get it?
Look at the triangle, and then look at the H, look at the polygon.
How do you find the sum of the interior angles of a polygon?
It's
The number of sides minus 2 to give you the number of triangles,
times 180.
and then times 180. So knowing that, you should have a calculator nearby. Find the sum of the interior angles of a 15-gon. Pentadecagon.
It's like 200.
Well, if it's a 15-gon, it has 15 sides. So how many triangles are inside a 15-gon? 13 triangles. How many degrees each?
180.
180. So 13 times 180 comes out to be 2,340 stinking degrees.
That's a lot.
That's a lot of degrees. Okay?
Guys.
So how do I get just one angle instead of the whole sum?
And then you divide it by...
So I take that total and divide it by what?
Oh, you divide it by n.
Divide it by the number of sides you have. Because this is the total number of degrees, but I'll have this many angles to share it out in a regular polygon. That doesn't work if it's not regular. Because then they might all be different sizes. Then, oh, you'll see. Don't worry. You'll see. Okay. So find the measure of one interior angle of a regular dodecagon. How many sides does a dodecagon have? 12 sides. Yeah. So how many triangles are there? 10 of them. How many degrees do they have? 180, which gives you 1,800, but I've got to share that among how many sides? 12 sides. So what is the measure of that angle?
150 degrees.
150 degrees. Not so bad, huh?
150.
Okay. Let's remind ourselves about exterior angles now. What do all of these 5 exterior angles, or any polygon, what do they always add up to?
360.
Always 360. They always add up to 360, which is really handy. So if I know how many sides I have, how do I figure out how big those angles are?
You can divide it 365.
You can take the 360 and divide it by,
5.
well, what if I, or whatever number, which is always what letter? N. Okay.
I forget, you guys.
Now, oh, wait, hold on. What's another way to find your exterior angles? Well, look, guys. Shh. Remember, exterior angles make a linear pair with your interior angles. Okay?
Oh, so it's divided by n.
So you could always do 180 minus the interior angle to find your exterior angle.
Yeah.
Could do that. So it just depends on what information you have. If you have the number of sides, you can do 360 divided by it to get your exterior angle. If you know about the interior angles, you can just use the supplementary stuff. Okay, so last one. Find the number of sides in a regular polygon. So we know it's regular, but we don't know its number of sides. If each interior angle is 160. What can we do? I want to find the number of sides. All I've got is interior angles. What do I know about the interior angles and the exterior angles?
Exterior angles out of 360.
The exteriors add up to 360, but I was given interior.
Oh, well, you can find the exterior because it's form a linear pair.
Yeah, the interiors are supplementary with the exteriors. So I could do 180 minus that 160 to get how big are my exterior angles?
20 degrees.
20 degrees.
That means,
But then,
yeah, 18.
if they're each 20 degrees, then 360 divided by the 20 degrees gives me how many sides?
18.
18, so this is an 18 gone.
I real smart. Gonna make.
Oh, we're done. Thank God.
Why do we have to do angles and convex polygons?